Alrighty then, corn children, children of the corn, we are going to take a look today at adding and subtracting with radical expressions. Before we do, though, let's remember something from the past, shall we? Let's remember combining like terms. If I had an example, x minus 3y plus 7x plus 10y, I am really confident that you're going to remember the following. These two terms are like terms. They have the same variable with the same exponent, x to the first, x to the first. So these two can be combined. And let's recall there's an understood 1 here. So 1, 7, 8x. We know this, right? This term with the y, this term with the y are also like terms. Y to the first, y to the first. We combine those and we get positive 7y. And what do we do now? We stop. That's as far as it gets to go because these are no longer like terms. Well, ladies and gentlemen, radicals happen the same way. No, yes, come along. Look at an example with some radicals. If I had the square root of 15, or radical 15, plus 8 radical 15, it's the exact same in my mind as x plus 8x. Yeah, there's an understood 1 here, and this would make 9 radical 15s. 1 radical 15 plus 8 more radical 15s is 9 radical 15s. That's excellent, isn't it? Okay, wait a minute. Let's try another. We're going to do like a little problem and another little problem and another. Check this one out. 3 radical 2 plus 4 radical 3 plus 7 radical 2 minus radical 3. Now what? Here's all I know. These are both radical 2's, aren't they? They both have square root of 2's. These are like terms. If we have 3 radical 2's here plus 7 radical 2's here, that makes 10 radical 2's. I combine those together. These are also combinable, if that's a word. These are radical 3's. These are radical 3's. Again, there's an understood 1. It's a negative 1. 4 radical 3's minus 1 radical 3's make 3 radical 3's. It's just like combining like terms. Awesome. Awesome. This is doable. We can do this. Okay, hold your horses, though. It's about to get a little bit harder. Oh, I got to go ruin it. I know. Check out this example with me. 4 radical 3 plus 2 radical 12. Now, if you've been paying attention, and hopefully you have, I mean, come on, you should say, well, these are not the same. You cannot combine them. Oh, but wait. 2 radical 12 is not fully simplified. Oh, yeah, we did that. 12 contains a factor that is a perfect square, specifically 4. We are going to simplify the radical first. All right, we can do that. Here we go. I'm just going to bring this one down. I'm not doing anything with this. 3 under the radical, you can't do anything there. There's the plus. There's the 2. Now, 12. Yes, I'm aware that 12 is 2 times 6. Not important. Don't care, because 2 and 6 are not perfect squares. Here's what I care about. 12 is 4 times 3, and 4 is a perfect square. It is 2 times 2. It is 2 squared. So we can break those apart, and the square root of 4 becomes a plain 2. Oh, I forgot to bring this down. Bring it down. Bring it down. Oh, now they're crooked. All right, so here's what we've got. This is 4 radical 3, and oh, this is 4 radical 3. They are like terms. 4 radical 3's plus 4 more radical 3's is 8 radical 3's. So when we started this problem, it didn't look like we could combine them. But having simplified this radical, and by all means, you are welcome to make some shortcuts in here. I skipped nothing. If you can make some shortcuts along the way, if you can get it down to 4 radical 3, you are working with like terms, and they can be combined. So yes, they were disguised as combinable, even though it didn't look like it. Hey, let's do another one of those. That's kind of tricky, isn't it? This one's even bigger. What? Here we go. 2 radical 45 plus 4 radical 20. And again, square root or radical is fine. All right. Right now, you cannot combine them because these are not the same radicals. But each one of these can be simplified. I'm going to do it a little bit faster this time. 45 has a perfect square as a factor. 9. If you don't remember your perfect squares, list them out. It's 9 times 5. Okay, there's the 2. The square root of 9 is a plain 3. No radical on that 3. The 5 has to stay under the square root. So that is 6 radical 5. The front term has simplified and reduced down to 6 radical 5. Let's look in the back now. Giant plus there. 20. It's 2 times 10. Don't care, don't care, don't care. Look for the perfect squares. Oh, it is 4 times 5. 4 is a perfect square. That I care about. The square root of 4, here's this 4 in front, bring it down. The square root of 4 is 2. And so this is 8 radical 5. Aw, look, you can combine them. 6 radical 5 plus 8 radical 5 is 14 radical 5. Hope you enjoyed that little video on adding radicals.